welcome to this tutorial on making a AAA style multiplayer FPS in Unity. So we are going to go straight from the beginning to building a pretty complicated system of a multiplayer FPS in Unity, and as you're going to see, we're going to be using some pretty advanced techniques to make sure that that's happening. Of course, this is going to be an ECS project. Not everything is going to be ECS. ECS is not always suitable for doing everything, but majority of the things that can be done in ECS will be done in ECS going forward. So the very first thing that you want to do, if you want to follow along with the tutorial, is head over to your Unity hub and make sure that you create a new project. Now, the Unity version that I'm going to be using is 2020.3.18f1. I do believe this is an LTS version. It's very important that we use exactly the same versions. As many of you might know, ECS is not always compatible with every single version of Unity. Even if they do say it is, it doesn't always work. So make sure you select HDRP. We're going to be using very high quality graphics in this project, and give the project whatever name you want, then select create project. It's done being created, Unity will start to import it. And what we have here is Unity's beautiful sample scene. HDRP is all set up, and that's good because that would have given us yet another piece of work to do setting up HDRP. Thankfully, we do not have to. So what we want to do now is install the ECS packages. This can be quite complicated sometimes, so to make it really easy, I've put a link in the description to my Discord. Once you head over to my Discord, you can simply head into the follow along channel we have for these Unity tutorials. You should be able to find this inside the channels page, follow FPS tutorial, and I've linked the manifest.json file that's needed to install all these packages into Unity without a single worry. I am going to use that exact same manifest.json, and I'm just going to import it into the project, and Unity will sort everything else out. Alright, so once the packages are done installing, we do still have some issues here in the console, and I'll just go through clearing these. Clearly what's happening, some assets in the sample scene assets appear to be requiring a package that's not necessarily installed. What I will do though is, particularly because these sample scene assets are not necessarily that important for us, I'll just go ahead and get rid of the scripts that do require these packages. Now that that's done, I do believe we have an asset called sample scene as well, and I'll delete that as well and just create our own new scene that we are going to be using to test out this game in the beginning. So I'll delete that as well, create a new scene. I'll go ahead and call this main, doesn't really matter what it's called, and open this up. Now do not save the sample scene, and now we're presented with a main scene that we can start to work on. What I do want to do here is just create a game object, and inside of script we're going to start by setting up our project layout. Now it's quite difficult to know exactly how important this is in Unity, but we're going to be setting up our assembly definitions. Most people will know the importance of assembly definitions, but essentially it's quite useful to make sure that your project builds really fast. This project is small at the moment, but in the future it's going to have hundreds of scripts, hundreds of files that could all recompile one of them. Assembly definitions make sure that we do not have to go through that problem. Secondly, we are going to be installing a procedure worlds package later on into this project, and procedure worlds packages are usually very big. They usually have very many scripts that are not assembly defined. Doing things in this way means that they will be assembly defined from the beginning, and they will not recompile every single time we make a change to our project. So to set this up, what I want to do first is create a new folder, and I'll call that main. Then we want to create a new folder and call this utils. We also want to create a new folder and just simply call this plugin. We also want yet another new folder, and I will call this standard assets. Quite important to get the spelling of standard assets correct in this case. Standard assets folder does not need to be inside of the scripts folder, so I'll move that back outside. Inside our main folder, we want to create a new assembly definition, and I'll just call this game.main. Later on we will have a game.main.editor assembly definition as well, which is not required at the moment, so I'll just not create it for now. Inside of our utils folder, we want to create yet another assembly definition, and I will call this game.utils. Once both of those are open, we want to go ahead and create a new script inside of the main folder, and I'll start by calling this script game. As you can imagine, this is going to be our main game loop. I'll open this inside of my code editor, and once it's up and running, we want to start by getting rid of all the boilerplate code. The very first thing we want to do in this new file is create an interface of iGameLoop. So what is this exactly? The game loops are going to be the different classes that will run our game. Each game loop has the ability to have a start and update function, and these start and update functions will be run as the typical start and update functions. Having them as separate interfaces means we can change what is running between the server and the client. Next thing we want to do is actually create the game class. So to do this, I'll simply create a new mono behavior, make sure that that's set up properly, and we want to import the needed usings in this case. Next, we want to give this class two very important variables. The game loop variable determines exactly what game loop is running for this particular client or server, depending on which one we're running, and the static game variable is just a store to make sure we know exactly what game is going to be running. This game object is going to be a singleton. Next, we want to add a start function. In the start function, we simply destroy this object if the game is not null. That means we already have a game, and then we save the current game if we did not destroy ourselves previously. And then we want to assign a game loop, which is going to be of new server game loop, which we are yet to create, and then we want to start it. So the start function of the server game loop does run at the same time as the start function of our game. Once it's started, we want to make sure that the cursor is locked and not visible, as this is important for testing player movement. While we're at it, let's add the update function. The update function simply checks if the game loop is not null. If it is not null, then it goes ahead and runs an update on it. Again, the game loop currently does run at the same rate as the game class. What we're going to do next is create a new server game loop class. Now, the differentiation that I'm using in this project is we have a main file, and then files that are meant strictly for the game go into the main file. Files that are meant strictly for the server will have a server file, and the client file will be there as well. So we're going to call this directory server, and then we're going to add a new script. Now, this is not going to be a mono behavior, but that's how Rider wants to do it at the moment. I will go ahead and call this server game loop, and we're going to get rid of the namespace and get rid of all the boilerplate code in here. Very important differentiations within this project. There is a server game loop, and there is also a server game world. The server game loop is mainly associated with dealing with network code. The server game world is associated with dealing with how that network code then affects the world. This differentiation is quite important, as you will see there is a lot of code that goes into creating these two individual classes. The fact that they're separate helps us maintain that code in a very easy way. So what we start by doing is creating a new class of type server game loop. This server game loop inherits from the iGameLoop interface, and this allows it to call the typical iGameLoop functions. It also allows us to assign it inside of this game loop variable here at the beginning. It's giving us errors at the moment, and it wants us to implement the members. Once again, the start function will run on the typical start rate, and the update function will run at the typical update rate at the moment. Now, like I said, we do have both a game world. So what we're going to do at the moment is simply create a variable that will store our server game world. This server game world, like I said, is quite important for managing things to do with the world. The next thing you want to do is actually create the server game world, and we simply create the world, and then what we want to do as well is add a constructor. Now, once the constructor is in, this is exactly what the server game loop is going to use to actually create this world. Server game loop in the start function, we want to simply assign our server game world to a new server game world. Now, it's quite important to note with this structure, in the future we will be passing certain variables from the server game loop into the server game world, but what we will not be doing is passing any variables from the game class into the server game loop. This is because the game class can either create a server game loop or a client game loop. In either case, we do not want to tie ourselves to having a specific game loop created at a specific time. That's why it's quite important to have the game static variable available within the game loop. Any function that wants to have access to certain things that are stored in the game can have functions to it, but it's not tied to a specific thing. The game class will be present on both the client and the server, and we don't want it to be tied to any particular one of those two. Now all that's left really is to test out this functionality. What I'm gonna do is within the server game loop, I'm gonna go ahead and console.log, and walking just lets us know that something is actually going on. So let's look at how this is going to work. Inside of the game class, we go ahead and make sure that we are assigned to an instance of the game. Then we create a new server game loop, and then we run start. If the server game loop is present, we update it every single frame. Let's head back to Unity and see how this is working. I just want to make sure that the game class is actually attached to the game object. And if I go ahead and press play, we should see a log in our console. And there you go. Now the console is collapsing messages, but you can see it's constantly logging working. Now that's pretty much it for this particular video. In the next video, we're going to look at creating the player. Again, the player has to be created in very specific ways, so we're going to be looking at in the next video. Catch you soon.